In this lesson, we will learn how to tackle questions where there is some kind of growth or decline over certain time periods. Take this question for example. Presently, there are 11 rats on a certain island. The rat population doubles every 3 months, and we want to determine the population 15 months from now. In this question, we are given information about incremental growth. That is, we are not told how the population behaves during the 3 months. All we know is that after 3 months, the population has doubled. In this question, we are also told that the growth period is 3 months. To solve this question, we will create a table with columns for time and population. In the time column, we will enter times that coincide with the growth period of 3 months. To begin, the question tells us that the current rat population is 11. So at time equals 0, we can enter a population of 11. Now after 3 months, the rat population doubles. So we could enter 22 for the population, but to show how the pattern behaves, let's say that the population at 3 months will be 11, the population at 0 months, times 2. Likewise, the population at 6 months will be twice the population at 3 months. So we can say that this population will be equal to the population at 3 months times 2. The population at 9 months will be equal to the population at 6 months times 2, and so on. Now the question asks us to find the population in 15 months. So we could evaluate this product, or we can simply write it as 11 times 2 to the power of 5. Alright, let's summarize. In this lesson, we learned that we can use a table to record and predict incremental growth or decline. In this lesson, we will learn how to tackle mixture questions such as the one shown here. Here we are combining two solutions, and we want to determine the concentration of salt in the resulting mixture. Now for all mixture questions, I recommend that we sketch any given mixtures such that the parts that make up the mixture are separated. So for this question, let's say that the bottom part is the salt portion of the mixture and the top part is something other than salt, say water. Now the question tells us that solution X is 30% salt by volume. So if there is 300 milliliters of solution X, and 30% of 300 is 90, then we know that there is 90 milliliters of salt in the solution. This means the remaining 210 milliliters of the solution must be water. Next we have 200 milliliters of solution Y, which we will also draw with the salt and water separated. The question tells us that solution Y is 70% salt by volume. So if there is 200 milliliters of solution Y and 70% of 200 is 140, then we know that there is 140 milliliters of salt in the solution. This means the remaining 60 milliliters of the solution must be water. Now when we combine these two solutions, we get a new solution which we will draw with the salt and water separated. To determine the various volumes of this new solution, we will combine like parts. First, since we are combining 300 milliliters of solution X and 200 milliliters of solution Y, the new solution will have a volume of 500 milliliters. Next, since solution X contains 90 milliliters of salt and solution Y contains 140 milliliters of salt, the new solution must have a total of 230 milliliters of salt. Finally, since solution X has 210 milliliters of water and solution Y has 60 milliliters of water, the new solution must have a total of 270 milliliters of water. Now if we express the salt concentration of the new solution as a fraction, it will equal the volume of salt over the total volume of the new solution. So in the new solution there is 230 milliliters of salt and there is 500 milliliters of solution in total. When we convert this fraction to a percent, we get 46%. So the new solution is 46% salt by volume. Alright, let's try another question. Here we have a 25% alcohol solution, and we want to determine how many milliliters of pure alcohol must be added to the solution so that the resulting solution is 60% alcohol by volume. So let's begin by sketching the initial solution with the water and alcohol separated. Now the question tells us that the initial solution is 25% alcohol by volume. So if there is 160 milliliters of solution and 25% of 160 is 40, then we know that there is 40 milliliters of alcohol in the solution. This means the remaining 120 milliliters must be water. Now to the solution, we want to add a certain amount of pure alcohol so that the new mixture is 60% alcohol by volume. Since we do not yet know how much alcohol needs to be added, let's say that we are adding X milliliters of alcohol. Now when we add these two solutions together, we get a new solution, which we will draw with the alcohol and water separated. To determine the various volumes of this new solution, we will combine like parts. First, since we are combining 160 milliliters of the original solution and X milliliters of alcohol, the new solution must have a volume of 160 plus X milliliters. Next, since the original solution contains 40 milliliters of alcohol and the other solution contains X milliliters of alcohol, the new solution must have a total of 40 plus X milliliters of alcohol. Finally, since the original solution contains 120 milliliters of water and the other solution contains no water, the new solution must contain 120 milliliters of water. Now the question tells us that we want the new solution to be 60% alcohol by volume. So we want the following fraction to equal 60%, or 60 over 100. Now from our sketch, we can see that the volume of alcohol in the new mixture is 40 plus X milliliters, and the total volume of the new mixture is 160 plus X milliliters. We want this fraction to equal 60%, so we will make it equal to 60 over 100. At this point, we have an equation we can solve for X. First, we can simplify the right-hand side to be 3/5. From here, we can cross-multiply to get the following, and then expand both sides. Now we can subtract 3x from both sides, then subtract 200 from both sides, and then divide both sides by 2 to get x equals 140. So we must add 140 milliliters of pure alcohol to the original solution to get a new solution that is 60% alcohol by volume. Alright, let's summarize. In this lesson, we learned to solve mixture problems by first sketching the solutions with the parts separated. Then we combine like parts to better understand the resulting solution.